In this video, we will walk you through the process of calculating and interpreting the titration of 0.1 m cocaine, a weak base, with 0.2 m nitric acid, a strong acid. The aim is to calculate the pH at various stages of the titration, sketch a titration curve, and identify a suitable indicator based on the equivalent point. Let's begin by identifying the important value. We are titrating 100 ml of 0.1 m cocaine with 0.2 m HNO3. The Kb equal to 2.6 times 10 to the power of negative 6. This is the equation. Cocaine acts as weak base, while nitric acid acts as strong acid to produce conjugate acid. Conjugate acid formed because cocaine accepts proton from nitric acid. Using formula M1V1 equal to M2V2, we can find volume of HNO3 needed to achieve equivalent point. After fill in the value of molarity and volume cocaine and also molarity HNO3, we found the volume of HNO3 needed, which is 50 ml. Next, we find pH before titration begin. Because titration does not even begin, no HNO3 is present. So we use this general equation. And we use Kb to find concentration of OH. We assume that concentration of conjugate acid and concentration of OH is similar. Thus, we label X. We fill in the Kb value and concentration of cocaine, which is base, and finally we got the concentration of OH minus, which is 5.099 times 10 to the power of negative 4.
To find pH, we need to find first pOH. Use negative log to find pOH and we get 3.29 minus the pOH with 14 and we got pH before titration, which is 10.71.
The question asks us to find pH value at this volume of acid added: 10, 20, 25, 30, 40, 49, 49.9, 50, 50.1, 51, and 60 ml. Let's go through example from before, at, and after the equivalent point.
First, we calculate pH after 10 ml of titrant has been added. We use Henderson-Hasselbalch equation to find pH in this step. First, we find pKb by negative log Kb, which result in 5.59. Next, we find concentration of base and conjugate acid. To find concentration of base, we use mv cocaine minus mv titrant divided by V total. Key in the molarity and volume for cocaine and molarity and volume added of nitric acid. Thus, the concentration of base is 0.0727 molarity. To find concentration of conjugate acid, we use mv titrant divided by V total. The concentration of conjugate acid is 0.0182 molarity. Fill in all the value in the Henderson-Hasselbalch equation and we got the pH value, which is 9.01. We use the same method to calculate pH before equivalence point for volume of acid added before equivalence point, which is 20 ml, 25 ml, 30 ml, 40 ml, 49 ml, and 49.9 ml. We use the same step to find the pH for every volume of acid added. At equivalence point, all base has been converted to its conjugate acid. Instead of Kb, we use Ka relationship to find pH. First, we need to find Ka by using Kw, which is water constant, because water constant equal to Ka multiplied by Kb. We got Ka equal to 3.849 multiplied by 10 to the power of -9. At equivalence point, moles of cocaine equal to moles of nitric acid. Predominant ion in solution is conjugate acid. Thus, we find the concentration of conjugate acid at equivalence point by using MV titration divided by V total, and we got 0.0667 molarity. We have diluted the sample, and the total volume at this point is 150 ml. We can assume that concentration of cocaine is negligible compared to concentration of cocaine cation. To find concentration of H+, we use Ka relationship based on this equation. We assume concentration of base equal to concentration of H+, thus we label it as X. Fill in all the value and we got concentration of H+ equal to 1.60 multiplied by 10 to the power of -5. To find pH, negative log concentration of H+, and we got pH 4.8 at equivalence point.
At this stage, all of the cocaine base has been neutralized, forming its conjugate acid. Any extra HNO3 added now result in excess strong acid in the solution. Because HNO3 is a strong acid, it dissociates completely and the pH is determined solely by the concentration of this excess H+. Let's calculate the pH when 50.1 ml of HNO3 has been added. First, determine the concentration of H+ using MV over V total. M represent molarity of acid. V represent the excess volume of acid added after equivalence point. For 50.1 ml of HNO3 added, there is 0.1 ml excess HNO3, so the molarity of acid is 0.2 m. The total volume is 150.1 ml. Thus, the concentration of H+ is 1.33 times 10 to the power of -4 m. To find the pH, negative log concentration of H+ and the pH will be 3.88. Same goes for over-titration by 1 ml and 10 ml, also using the same step. This is the graph of pH versus volume of HNO3 added. The graph clearly indicates the inflection point at pH 4.8. Since the equivalence point is around pH 4.8, we need an indicator that changes color around this value. One good choice is methyl orange, which change color between pH 3.1 and 4.4. This range covers the sharp drop seen on the graph.